Heisenberg's uncertainty principle states that the uncertainty in distance multiplied by the uncertainty momentum is greater than half the reduced Planck constant. But what does this have to do with real life and the way the universe works?
Yeah, that's the most famous version of the principle. And what basically states is that you can't know everything at the same time. That there are pairs of things, like you said, the position momentum, that you can't know them precisely at the same time. So if you start knowing more about one, you lose track of the other one. That's pretty much what the idea is.
So what is the purpose of this complicated formula, and where does it come from?
Yeah, it comes from trying to figure out what happens when you measure two things at once. Because when you're trying to do the maths for these things, well, in maths there's no way of doing two things at the same time. You have these things in maths that do one measurement or then the other one. But if you apply things in reverse order, sometimes you get different results. And if you get different results depending on the order, we don't really know what should happen when we wanted to figure two things out exactly at the same time. And the formula is a way of figuring out how uncertain we are about doing all at the same time, from figuring one then the other, or in the opposite order.
So can you give some day-to-day examples to help us understand the uncertainty principle?
Yeah. Well, the uncertainty principle, we don't see a lot of it in our daily life. Actually, we don't see at the scale of our senses. We don't feel any of it with our senses. But if you would see something like, let's say you're playing marbles, trying to throw a piece of something somewhere. The problem is you cannot see at the same time where that marble is, the position, and how it's moving, what its velocity is, where it's going, how fast it's going. So if you want to play marble, well, you want to hit another one, and you want to judge the speed and the direction where to go. You can't do these things out to absolute precision. It messes things up a bit. So that's the uncertainty principle.
Why is this seemingly simple principle important in the complicated world of quantum mechanics?
Yeah, it's extremely important, because what it tells us is that, all these things that we need to know to figure out what the life, the universe, and everything is made of, how this thing works, we cannot know them at the same time. And it's not a limitation because something that we can improve, it's something that is part of what these things are. There's no way we will ever figure everything out very precisely about everything at the same time.
How would you go about explaining the uncertainty principle in a quantum mechanics lecture, for instance?
Yeah, well, the key thing is to try and convince people that there are these things that are relevant for us to figure out as scientists, that won't be the same if you do measure one thing then the other, or if you do the other and then the one. Use the opposite order. To just use, I start with always with a very familiar example. Ask people, would you rather live before you die, or would you rather die before you live? It's an enormous difference between these two things. But there are things, on the other hand, where it makes no difference. And then I use a silly example, like, say, if you eat fish and chips, if you first have a mouthful of fish, then some chips, or the other way around, doesn't really make that much difference. Might as well have everything at the same time. The taste is pretty much the same.
So you've thought this through then to be able to get to that?
Yeah, because I have to introduce this thing, Jen, because the maths gets a little bit abstract, and it's important not to lose track of the really important ideas that are there behind the maths.
So could you summarize the uncertainty principle beyond the mathematical formula?
Yes, the key thing is really this, is that, when we look at the universe, the things that are around us, the world, we need to figure out lots of things about this complex stuff to really have a good grip on what they are, what they do, and so on. But what the uncertainty principle says is this: you cannot figure everything out. There are pairs of things that if you start to zoom in on one thing, then you lose track of the other one. There is a compromise to be had there. That is really the key message.
So, is the uncertainty principle relevant in disciplines outside of science?
Oh yes, very much, because it's such a basic thing. So it says it's a limitation for all of science, and by extension to all of our knowledge, the things that we can know about. In particular, philosophers spend a lot of time discussing the uncertainty principle and what it means in terms of our capacity to learn about the world, to think about the world, about what reality really is. Philosophers discuss that a lot. In fact, philosophers have 3 different interpretations of what the uncertainty principle actually means.
So what are the philosophical interpretations of the uncertainty principle?
Okay, so you have these 2 things, let's say, there's lots of pairs, but let's say you have 2 things that you cannot know at the same time, right? So one way of thinking about this is to say, well, there's some intrinsic limitation about the measurements that we can make. We are never going to build perfect machines. It's a little bit like we have a vacuum cleaner that will say, well, it's not getting all the dust in the room. If I make a better one, it will get all the dust. But in the case of the uncertainty principle, there's some limitation there that says, doesn't matter how good your machines get, you will never beat this. It's a limitation of nature, not of the machine. That's vision number 1. Vision number 2 says, well, it's not a problem of the machines. The machines are all right. We can keep improving them. The problem is with the ideas that we use. There are some ideas that they are, in a way, incompatible with each other. If you start sharpening your idea and getting details about it and numbers and precision, you lose track of the other one. So this second view says, there's no problem with machines. We can improve the machines and keep improving. The problem is with the ideas, the concepts that we use to think about them. And we can't have a set of concepts that is going to allow for perfectly good description of everything. So, idea number 1, there's a limitation with measurements. Idea number 2, there's a limitation with ideas. Idea number 3 is that there's no limitation with anything. Reality is like that. Things really are imprecise and not sharply defined, unlike we naturally tend to think.
So finally, I'd like to ask, after all that philosophy, how I could understand the uncertainty principle if I found someone I like the look of on the dance floor on a Saturday night.
Okay, Adil, let's say you go to a club on Saturday night, you're out on Leeds clubs. If you were tiny little Adil and you were fancying some tiny little dancer on the dance floor, chances were you would start to try to get closer to that dancer and dance along. Trouble is, the moment that you started figuring out where that dancer is, you lose track of how the dancer is moving. So you cannot get close to the dancer and dance along at the same time. Luckily for you, my friend, you are not that tiny, so at the scale that you inhabit the universe, you won't see any of this. So get out on that dance floor, get your hip shaking, and good luck with your pulling on Saturday night.